We're going to start with number 3. We have log base 4 of 16. So what I'm going to do is I'm going to write the inverse. We have 4, because that's the base. Remember that this is the exponent. 4 to some power gives you 16. So you know that 4 to the second power gives you 16. And that's how you evaluate the expression. What you need to remember is that this will be the power. And of course, this is the base. And this is the answer, right? To expand the logarithm, that means to write more than write it in terms of more than one logarithm. So you notice that you have natural log of 11 times 10 to the 4th divided by 7 to the 4th. So what you're going to do is you're going to use the quotient rule. So you have natural log of 11 times 10 to the 4th minus natural log of 7 to the 4th. Now we can further expand. So you're going to have, since you're multiplying 11 times 10 to the 4th, you have natural log of 11 plus natural log of 10 to the 4th minus natural log of 7 to the 4th. Remember the power property? The power property states that the 4 can be written as a product of the logarithm. So both 4s can be written as a product. So you have natural log of 11 plus 4 times the natural log of 10 minus 4 times the natural log of 7. Okay, so the answer will be the natural log of 11 plus 4 times the natural log of 10 minus 4 times the natural log of 7. So your answer is B. What we're going to do here is we're going to condense each expression to a single logarithm. So like for number 7, you notice that we have all bases are the same, base 2. And we're adding. So more than likely, we're going to use the product property. But you notice that we have a 4 here. And we also have a 4 here. And we also have a 24. That means I can rewrite this as each of them as an exponent. So you have log base 2. And you have 3 to the 4th power plus log base 2, 10 to the 4th power plus log base 2 of 7th to the 24th power. And since we're adding and we want to make it into a single log, all you have to do is use the product property and multiply. So we have log base 2, and we have 3 to the 4th times 10 to the 4th times 7 to the 24th. So your answer to this problem, or the correct expression, is D. So just to review, we use the power property, and then we use the product property. Number 9, we're going to go ahead and solve this log equation, but we got to make it into a single log. And you notice that we have 2 logarithms, log base 5 of x minus 6 and log base 5 of 3 equals 2. So we have to make it into a single log, so we're going to use the product property. So we have log base 5, and you notice we're going to have to multiply x minus 6 times 3. So you have 3 times x minus 6 equals 2. Now what you have to do is you have to write the inverse. And to write the inverse, you have to identify the base. You have to identify the exponent. And you have to identify the answer, right? So the base here is 5. The exponent is 2. And what is this going to equal to is 3 times x minus 6. Now you're just going to solve this as a regular equation. So you have 25 equals 3x minus 18. You add 18 to both sides. So you have 43 equals 3x. And then you divide by 3. So your answer is A. Now remember the way I taught you in class how to check. You substitute. So in your calculator, you would type in log. And then the base is 5. And then what you would type in is parentheses. 43 over 3 minus 6 plus log base 5 of 3. And remember, you would want to get 2. What you're going to do here is we're going to solve each equation and then round our answer. So we have 2 raised to the power 2a plus 3.6 equals 66. So what you want to do first is isolate the exponent, or the exponential part, which is 2 to the power 2a. So you subtract 3.6 from 66. So you get 2 to the power 2a equals 66 minus 3.6. And you get 62.4. Remember what I taught you. We can't find a common base, so we have to introduce logarithm. So we're going to write log of, and this is base 10, of 2 to the a is equal to log base 10 of 62.4. So you're going to write the 2a to the side. So you have 2a times the log of 2 equals the log of 62.4. What you do next is you divide by 2 log of 2, right? So we divide by 2 log of 2. 2 divided by 2 is 1. Log base 10 of 2 and log base 10 of 2 is 1. So you're left with A. So you go to your calculator, you type in log, and by default, it is base 10 in your TI Inspire, and then you write 62.4, and then you write divided by log base 10, and of course you have to include the 2. There was a 2. So your answer will be 2.9817. And if you want to check it, it'd be 2, and then you'd substitute 2 times 2.9817, and then of course you're adding 3.6, and you will approximately get 66. You won't exactly get 66, but you'll get close to 66. We're solving this equation. We have 1 equals square root of b plus 9. Since we're dealing with a square root, we're going to get the square of the right side. So definitely you have to get the square of the left side. So 1 squared is 1. Once you square a square root, you get whatever's in the radical. So it's b plus 9. You want to isolate the b, so you subtract 9. 9 minus 9 is 0. 1 minus 9 is negative 8 equals b. So if you want to check, you would have to substitute. So does 1 equal the square root of negative 8 plus 9? And you notice that it does. For number 15, we're naming the polynomial by degree and the number of terms. You notice that we have 2 terms, so automatically D is eliminated. And we notice that the 5th power is the highest power, and we know quintec is a polynomial with the 5th power, so your answer is B. We're going to simplify number 17, and what I like to do is I like to write it out. So you have 4 times x to the 4th minus 7x squared plus 3x minus 3x to the 3rd. And you see that 4x to the 4th is going to be negative 4x to the 4th. It's going to change the sign. And then the last one's negative 6x, so it's going to be positive 6x. You got to be real careful and make sure that you have the correct terms, because it's real easy to mess up here. So I have 4x to the 4th, and I have negative 4x to the 4th, so that's going to become 0. So now I have negative 7x squared. So do I have another x squared? No. So it's negative 7x squared, so I'm going to cancel that there. I'm going to eliminate it. Do I have another x? I do. 3x and 6x is 9x. So I'm going to go ahead and mark those out. And of course, our highest exponent is 3, so it's going to be our leading term. So we have negative 3x cubed, right? So which one has negative 3x cubed minus 7x squared plus 9x? So the answer is D. Number 19, I'm gonna go ahead and multiply, and I'm gonna show you how to multiply here. You have 3r times 6r squared gives you 18r squared. 3r times 7r gives you 21r. 3r times negative 3 gives you negative 9. So just to check, 3r times 6r squared gives you, there was my mistake, it's 18r cubed. And then 3r times 7r is 21r squared. And then 3r times negative 3 gives you negative 9r, right? Now you're going to multiply 5 times 6r squared. So that's plus 30r squared. 5 times 7r gives you 35r. 5 times negative 3 gives you negative 15. So do I have r to the 3rd power? No. So what I'm going to do is I'm going to mark that out. So you have 18r cubed. The next one is r squared. I have 21 plus 30, so that's going to give me 51r squared. Negative 9r plus 35 will be 26r. Minus 15. So your answer is D. We're going to factor x squared minus x minus 20. You need to find the factors of negative 20 that add up to give you negative 1, the middle coefficient. And we notice we have negative 20 and 1, negative 10 and 2, negative 5 and 4. And if I do negative 20 plus 1, that gets negative 19. That's not going to be it. Negative 10 plus 2 is negative 8. That's not going to work. Negative 5 plus 4 is negative 1. That's going to work. So what are the factors? X minus 5 times x plus 4 and we set it equal to 0. So your answer is A. Okay, we're going to factor x cubed minus 8. So remember the formula I shared with you? A difference of cubes is going to be a minus b, a squared plus ab plus b squared. So let me rewrite this. We have x to the third power minus, 2 to the third. So what are the factors? Well, the first one is x minus 2. Remember, the first term is squared, so it's x squared plus 2x plus 4, right? So your answer is B. 25, evaluate each function at the given value using synthetic division. So we want to figure out f of negative 4. Remember, we're going to write negative 4. And then we start listing the coefficients. So you have 2, 9, 4, 1, 3. So 2, you bring it down. Negative 4 times 2. You multiply negative 4 times 2, which is negative 8. 9 plus negative 8 is 1. Negative 4 times 1 is negative 4. 4 minus 4 is 0. Negative 4 times 0 is 0. Negative 4 times 0 is 0. 1 plus 0 is 1. Negative 4 times 1 is negative 4. 3 minus 4, 3 plus negative 4 is negative 1. So what is f of negative 4? It's negative 1. If you want to check, then what you do in your calculator, you type in 2 parentheses negative 1 to the fourth, negative 4 to the fourth power plus 9 times negative 4 to the third power plus 4 times negative 4 to the second power minus 4 plus 3, and I ran out of room. So you basically substitute. 27 will be the open-ended question. 28 will be the open-ended question. So 27, you can use synthetic division if you want. 28 will be the open-ended question. So I'm gonna just like you were taking the test, I'm gonna go ahead and use synthetic division. So you have a minus 9, so it's gonna be 9. So you start listing your coefficients: 1, 1, negative 82, negative 81. You bring down the 1. 9 times 1 is 9. 1 plus 9 is 10. 9 times 10 is 90. Negative 82 plus 90 is 8. 9 times 8 is 72. And negative 81 plus 72 is negative 9. You notice that the highest power was 3. So this will be a squared plus 10a plus 8. This is the remainder. So it's minus 9 over a minus 9. So your answer is B.